My dear students, now we are going to look at flip-flop conversions. So, what are the flip-flops that we have and what are the possible conversions that we are going to look at? And we would like to look at the truth tables of the flip-flops, then followed by the basic conversion principle. So, the main objective is to do the conversion. So, let's look at the possible flip-flops that we have studied already. We know SR flip-flop, it is also known as set reset flip-flop. Then we have JK flip-flop. Then we have SR, JK, T flip-flop and a D flip-flop. T flip-flop and T flip-flop. Now if at all you want to look for the possible conversions, we have SR. From there we can go to JK, we can go to D, we can convert it to T. Then if I take JK flip-flop, from JK I can convert it to SR, I can convert it to D, I can convert it to T. If I take D flip-flop, I can convert it into SR, I can convert it into JK, I can convert it into T. If I take T flip-flop, I can convert it into SR, I can convert it into JK, I can convert it into T. So these are the possible conversions. We will look at all possible conversions. To do any conversion, we should know the flip-flop itself. So every flip-flop is having its own truth table. For SR flip-flop, if we to take the truth table, you can take the truth table something like this. There will be certain inputs, there will be a present state, in short I am writing PS, there is a next state. So the inputs are S and R, set reset. Present state is say Qn, next state is Qn plus 1. Okay. So as it is a sequential circuit, present inputs, present state decides the next state. So the inputs are 0, 0, 0, 0, 0, 1, 0, 0, sorry, 0, 1, 0, okay, 0, 1, 0, then 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So what is the next state that I am going to get is when S inputs and R inputs are 0, 0, your present next state is nothing but the present state. That means 0 and 1. Because in this case here these four zeros, that is 0, 0, 0, 0. What it means, S is equals to R is equals to 0. So here what exactly that is happening is next state is nothing but present state. So you are not asking for set, you are not asking for reset. So it is no change state. Now when you are saying 0, 1, 0, 1, S is equals to 0, or you are asking it to reset. So your next state will be 0. When you are asking it to set, the next state will be 1. When you are asking for set and reset, so don't care, I can say indeterminate. We can't find indeterminate. Okay. So this is about SR. If you look at the JK, it is same as SR except for the last case. So let's look at that. So inputs, present state, next state. What is present inputs? J and K, Qn, Qn plus 1. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. When J is equal to 0, K is equal to 0. These two cases 0, 1, no change. Okay. When 0, 1, your K is going to act as a reset. So when this is 1 and this is 1, output is 0. When you are asking for set, output is 1. But last two cases, if present state is 0, next state will be 1. If present state is 1, next state is 0. Okay. We can also write this in a short form wherein J, K, Qn plus 1. When j is equal to 0, q is equal to k equal to 0, it is qn. When 0 1, it is 0. For 1 0, it is 1. For 1 1, it is qn bar. Okay, this is in short form. Same truth table. Why? It is input output relations. This is input, whereas this is output. Okay, output expressed in terms of present state. What is output exactly? Next state. So always qn is present state. Qn is present state. Okay, then qn plus 1 is next state, right? So similarly, whatever we have seen with respect to the jk, we can also see in case of sr 2. So in sr, what I try to do is I write in short form. Say sr qn plus 1. For 0 0 qn, for 0 1 output is 0, for 1 0 output is 1, for 1 1 we don't know, and internet, right? So once we know the truth tables for S and SR and JK, we will look at the truth table for D and T. For a D flip flop, if I look at for a D flip flop, let's have the inputs D. Okay, for a D flip flop, the inputs D and Q, Qn and Qn plus 1. So possibilities are 0 0, 0 1, 1 0, 1 1. The D flip flop, the name itself says delay flip flop. The next state doesn't depend on present state. Next state is nothing but data input. That means it is same as D. So when D is 0, Qn plus 1 is also 0. When D is 1, Qn plus 1 is 1. So it is same as, what I mean to say here is, it is same as D. So what I am seeing here, okay, I also see here. That is the fundamental output. This is input, that is output. So these are inputs, of course, and whereas this is output. Okay, so next what I try to do is we will look at T flip flop. For a T flip flop, let's look at the inputs. So inputs, outputs. What are the outputs? Outputs is Qm plus 1. Inputs is T and Qn, of course, along with the present state Qn. So now look at the set of possibilities 0 0, 0 1, 1 0, 1 1. For 0 0 and 0 1. So for 0 0, when t is equals to 0, next state is same as present state. It means to say 0 and 1. When t is equals to 1, next state is complement of present state. Complement of present state. 0 is 1, 1 is 0. So I can also write this in short form, that is t qn plus 1. Same truth table. So for 0, it is qn. For 1, it is qn bar. For a d flip flop, also possible to write in a short form, d qn plus 1. Same truth table. When 0, qn plus 1 is 0. When 1, qn plus is 1. So this is all about the flip flop truth tables. Once we know this, then it's very simple, the conversion process. The conversion process will start like this. I'll take up a given flip flop. Some a flip flop is given to me. Some flip flop given flip flop. For that given flip flop, I am getting output Qn and Qn bar. That's fine. So I have some conversion logic. Some combination circuit I am going to build it in order to convert that circuit. Okay. So there will be inputs. Inputs are based on this feedback. I can use both Qn and Qn bar and flip flop inputs. So these are FF flip flop inputs. Okay. This is flip flop conversion logic. Conversion logic. So what we do is we'll design this circuit. This is already given. This circuit is of combinational in nature. Conversion logic is combinational circuit. The overall circuit is sequential circuit. Okay. So example, what exactly? Let's suppose I want to convert SR to JK. Okay. So what we try to do is SR to JK. What is given flip flop? SR flip flop. Okay. What are the flip flop inputs? It's look like I'm converting SR to JK. That means inside there is a SR flip flop, but it look like JK. So inputs are J and K. Okay. So here input is S, here input is R. Here inputs are JK. So now what I am trying to do is, if you look at this circuit, I need to get S, I need to get expression for R. So if you look at S, what are the input? These are the outputs with respect to conversion logic. This is S, this is R. What are the inputs? J, K, Q, and Q and bar. So S is a function of what exactly it is? J, K, Q, N, Q and bar. Okay. What about R? R is a function of J, K, okay, Q, N, and Q and bar. So what we try to do is we try to get an expression for S in terms of J, K, Q, N, and Q N bar, and we also try to get an expression for R. Okay. So with that, what exactly it is going to get is you are going to get a circuitry, some set of logic gates we will be using. Then we are going to get our overall converted flip flop. Okay. SR as converted as JK. So when we can say that SR is converted to JK, what is SR to JK is whatever the expected output from SR and JK. When we can say that two flip flops are equal. If I have a flip flop 1, say SR flip flop, okay, it is producing an output Qn plus 1. If same output is produced by, let's say, JK, okay, so what exactly I can do is I look for the both the flip flops, the output should be same. If SR is producing some output, okay, and if JK is also producing the same output, okay, then I can say SR flip flop is equivalent to JK. Okay, so that is what exactly we try to do. So what we try to do is for a given flip flop, so what we write the truth table, and the same truth table we try to get it from the other. Okay. So in the next lecture we are going to look at one sample example, okay, wherein we are going to convert one flip flop to another flip flop.